using CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. So the first step in this is using what we've been learning the last few lessons. First, we need to prove that the two triangles are congruent using either SSS, SAS, ASA, AAS, or HL. After we've proved that the two triangles are congruent, we use step 2, which is that all of the remaining corresponding sides and angles are now congruent. So that means that all of the rest of the sides and angles that don't have congruent tick marks or arc marks on them, you can now match them up and say that they are the same. So the way that we're going to use CPCTC is in proofs. So let's go ahead and walk through this proof. First, we're given that angle ABD is congruent to angle CBD. So they're both marked with 1. And then angle BDA and angle BDC are both congruent, so they're marked with 2. We need to prove, now I'm just going to make this marking, that AB, segment AB is congruent to segment CB. So we want to say that AB is congruent to CB. Now that's the very last step, but how do we get there? We don't have any segment measurements to be able to tell us that those are the same. So what we're going to do is we're going to take our step 1. First, let's prove that those triangles are congruent first. So in our proof, it says in step 3, segment BD is congruent to segment BD. So why can we say that this segment is congruent to itself? And remember, any segment congruent to itself, that's using the reflexive property. Now we can say that triangle ABD is congruent to triangle CBD using angle side angle. Now the reason why it's angle side angle, remember these green tick markings, we don't know that yet. That's what we're trying to prove. So you can't consider that when you're trying to decide how the triangles are congruent. So the information we have are angle, side, angle. Now, once we've proven that the two triangles are congruent, we can actually say all the rest of the sides and angles that are corresponding are congruent. So angle A is congruent to angle C. Those are the last sets of angles. And then side AD is congruent to side DC. So in saying that segment AB is congruent to CB, that's using CPCTC. So we'll walk through one more proof together. Here it says that angle BAE, that's this angle, is congruent to angle BCD. That's this angle. And that's what we're given. And then segment AB is congruent to segment CB. So I'm just going to mark those here. And then it wants us to use the reflexive property. Now what could be exactly the same in both triangles? So we're talking about this angle B. Remember, this goes back to our overlapping triangles. So angle B is congruent to itself. Now in your word bank you have segment AB congruent to AB, which is true for the reflexive property, but that's not going to help us in our proof. So we can go ahead and mark that in our diagram. And then triangle ABE is congruent to CBD using what property? So ABE is congruent to CBD using angle side angle. Now that we have that the two triangles are congruent, we can say the remaining sides and angles are congruent. So this side DC is going to be congruent to AE, and then the rest of the angles. So we can say that BE, this short segment right here, is congruent to DB, again using CPCTC. Now we'll get a lot more practice in using CPCTC with proofs in class, but that's it for this lesson.